This tutorial walks through a meshless static stress analysis of an engine bracket in Nodi. To bring the part in, we use an import geometry node and load the step file. When importing a step file, the model can also be loaded as a mesh. But since we will use the surfaces as boundary conditions in a later step, we leave the mesh import option off. To pick the surfaces where the load will be applied, we use a BREP select node in face mode and click the inner cylindrical faces of the two lug holes. To define the mounting surfaces, we use a second BREP select node and select all 4 bolt holes, labeling it fixed surface. We connect the mounting surfaces we just selected to a fixed BC node and the load surfaces to a force BC node. To define the load itself, we use a unit Z node with its factor set to 10,000, giving a 10,000 Newton force along the positive Z axis. To combine the boundary conditions, we use a merge node with its input set to 3. To specify the material, we use an Isotropic Material node, defining steel with a Young's modulus of 210 gigapascals, a Poisson's ratio of 0.3, and a density of 7,800. To collapse everything into a single list for the solver, we use a Flatten Tree node after the merge. To check the setup visually, we use an Implicit BC Display node. The force faces appear in pink and the fixed faces in cyan. To run the analysis, we add an implicit static stress solver node and wire the flattened configurations into it. The solver also needs the part as an implicit body, so we use a BREP2 implicit node fed from the imported geometry. The default tolerance would require far too many elements, so we raise the tolerance to 1 and set the half bandwidth to 3. The solve now completes, returning displacement, stress, von Mises stress, strain, and distance fields. To visualize the solver output directly on the part, we use an analysis display node with the jet color map. Wiring in the solver's fields and the implicit body, it first renders the displacement field with a legend in the viewport. Switching the field to Mises stress renders the von Mises stress heat map. Stress concentrates around the loaded lug holes while the base stays in the low blue range. That completes the stress analysis workflow in Nodi.